So now let's do some examples here where we're given a polynomial and one of its factors, and we're going to write the function in factored form. So in problem number 7, you've got this cubic polynomial here, p of x equals 2x cubed minus 9x squared plus x plus 12, and you know that one of its factors is x minus 4. Now, because we know that x minus 4 is one of its factors, we can do long division on this polynomial to reduce the polynomial to a quadratic and then try to find the factors of the quadratic. So we need to do polynomial division. Now here's the thing. We could use long division for polynomials, but when we have a factor that's of this form, x minus a number or x plus a number, you can use your synthetic division. And here's how that works. X minus 4, just take that x minus 4, set it to 0, okay? And then we're going to solve for x. So x equals 4. So that 4 is going to go in the little box. So you're going to put a little box on the left corner of your paper, and the 4 goes there. And now in synthetic division, we use the coefficients of p. And then we make sure that all of the powers are represented, all the powers of x. So we have x to the third, x to the second, and x to the first. So all the powers are represented, and then we have our constant. So we're going to just rewrite these coefficients here. 2, negative 9, a 1 for this third term, and then the 12. Okay, and then leave 1 row's worth of space there. And with synthetic division, we bring down the first term, and then you're going to take the 2 and multiply times the 4 and put that answer here. So 2 times 4 is 8. Add these together so you get a negative 1. Okay, repeat the process. Negative 1 times 4 is negative 4. Add these together, you get negative 3. Then negative 3 times 4 is negative 12. And here we get 0. This is good news because by having a 0 remainder, this last number is always the remainder when we do division. That means that x minus 4 is a factor, okay? So we expected that 0. All right, so now this is a quadratic equation. So these are the coefficients. You go down 1 degree. So p was x to the third. So this is going to be 2x squared. So let's see here. Let's use a different color. So 2x squared and then minus 1x minus 3. So this is our new polynomial that we have to factor. And for that, we're just going to use our factoring. I'm going to put 2x and x here for these two, and then negative 3 and a positive 1 here. Okay, and so that's my factored form for this quadratic. Now, I did this kind of by trial and error, just looking at it because the numbers were small. But remember that we can use other methods to factor these quadratics. For example, we could use the bottoms up method, right? Okay, so now what's the factored form of p of x? Well, p of x is going to be given by x minus 4. So that was the original factor, right? We were given that, times 2x minus 3 times x plus 1. And so there's your factor form for p. Okay, let's take a look at number 8. So now number 8, I want you to notice you once again have a polynomial that's a cubic, right? X to the third degree 3, okay? And this time the factor is 2x plus 1. So now notice that this factor does not look like this one. It's not x minus a number or x plus a number with a 1x here. This one's got a 2x. Do you see that? So that means we're kind of stuck. We have to do long division. So we're going to do the long division now. Out here we have the 2x plus 1. And then in here we're going to put the 2x to the third plus 3x squared minus 11x minus 6. Okay, good. And so now we divide. We look at this 2x and add that 2x cubed. And we know that if we divide these two terms, we would get x squared, right? So now take x squared and multiply times both of these and line them up. They go under here, under each of these terms. So that would be 2x cubed plus 1x squared. Okay, so here's the thing. A lot of my students sometimes forget this next step, which is that we have to subtract. So I always recommend get a different color and then change these signs. So subtract, subtract, okay? And now Notice how here we get 0. That needs to happen because you picked this factor up here so that it would be a 0. Okay, and then here we get what? 2x squared. Bring down the next term, which is a negative 11x, and repeat the process. So now we're going to divide 2x into 2x squared, which is a plus 1x, a positive x, right? And then multiply the x times both of these terms and line them up. So x times 2x is 2x squared, and then the x times 1 is plus 1x. Okay, now, again, here's where you want to use your other color and subtract. So change your signs. And this gives you 0, which was expected. And here we get a negative 12x. And now we're going to bring down the negative 6. And repeat the process one more time. So 2x divided into negative 12x is a negative 6. And then multiply your negative 6 times the 2x plus 1 and line up your terms. So that's negative 12x minus 6. And then again, we're confirming when we subtract that change these signs that we do get a 0 remainder. Okay? And that needs to happen because 2x plus 1, we were given that that's one of the factors of p. So this remainder should be 0. If it isn't, then check your signs and see if you missed a sign somewhere. Okay, so now this quadratic we need to factor. X squared plus x minus 6. And this one's not too tough, right? Because we need two numbers that multiply to negative 6 and add up to a 1, a positive 1. So that would be x plus 3 times x minus 2. And so now we know that our p of x in factored form will be 2x plus 1 that was given times x plus 3 x minus 2. By the way, do you know how to check your answers? Do you know that you can just FOIL these two and then FOIL it times this, take that answer times this and see if you get back your original? Okay. All right. I'm not going to do that in this video, but you can do that. Okay. Here's the last one for the video. Got kind of some big numbers here, but now we have a x to the 4th. You see that? We have a degree 4 polynomial, but here's the good news. This is an x plus 7, so we can use our synthetic division. Remember, x plus 7 equals 0. Solve for x, so the negative 7 is what's going to go in your little box here, okay, in your synthetic division. And then you're going to write these numbers. So these coefficients, so 3, 9, negative 72, 84. And guess what? There's a missing term. Did you notice that our constant was missing? Well, I need to put a 0 placeholder for that. Okay, so we didn't have a constant here, so we have to put a 0 there. Bring down the first coefficient, multiply times the negative 7, add these, and that's a negative 12, okay? Multiply this times the negative 7, which is a positive 84. Add these, that's a positive 12. Multiply the 12 times the negative 7, which is a negative 84. And we get a 0. And then we get a 0. 0 times negative 7 is 0. Okay, cool. This cubic, now remember, this is, even though there's only 3 coefficients, you go down 1 degree. So this was an x to the 4th. This coefficient belongs to x to the 3rd. Okay, so we're going to write 3x cubed minus 12x squared plus 12x, and then you don't have to write plus 0. But it is implied this is a plus 0 because this is your remainder. Remember, this last number is the remainder. This is your constant, and there's no constant. But we do have to factor this guy, don't we? And actually, we're going to be happy that we don't have that constant. Can you see why? Yeah, because there's a GCF here. Do you know the greatest common factor? So the greatest common factor is 3x. So we're going to go ahead and factor that out first. And then that's going to leave us with x squared minus 4x and then plus 4 right there. Okay. Oh, hopefully you recognize that perfect square trinomial there. So this is x minus 2 times x minus 2 for this quadratic. So let's give the final answer here with p of x, right? So p of x in factored form, we've got the x plus 7 that was given. Hang on. So p of x, I always like to put the GCF in front, 3x times the x plus 7 that was given times x minus 2, two of them. So if you want to put x minus 2 squared, then that's okay.